we can actually simplify that a little bit and say that a vector is a directed line segment.
Magnitude.
It's a directed line segment. And it possesses, because it is a directed segment, it possesses magnitude and direction. Okay? Now, for those of you not in physics, the study of vectors and matrices, and they go together, so we're going to do a little bit of both. The study of vectors and matrices has its own vocabulary. Magnitude is just the vector word for length. So when we say we're a directed line segment, do line segments have length? Yeah, they go from point A to point B, they have a length. But unlike a segment, a vector also has direction. Okay, so you're moving specifically from point P to point Q. Okay, now, find the coordinates of the vector from -3, 2 to 7, 1. Now, I should have given these, named those points. These are just ordered pairs. And we want to know the coordinates of the vector that goes from A to B. Okay? Now, any guess as to what the coordinates of that vector might be? Describe that motion. What are we doing when we go from here to here?
10, -4.
What'd you say?
Like 10 and then -1.
That's exactly right, 10, -1. So I don't know what's going through Brian's mind, I rarely do, but think about it as slope. How is this thing moving? Over and up, right? How far over is it going? 10. How far up is it going? -1. Does that make sense? Easy.
How did I cheat?
All right, next. Now we have a couple of vectors. And this is done differently in different textbooks and different, teachers do this differently. In the AP materials, vectors are denoted with this these things, like greater thans and less thans. And I think they do that to distinguish it from an ordered pair. This means a point. This notation tells you you have a vector. So we want to know this and this. Now, I think you can figure that one out pretty easily. What do you think that is?
6 -8.
In vector land, this number right here, Brian, what's that called?
No idea.
Scalar. That's called a scalar. Again, the concepts are the same. This is a coefficient. And what did we just do? We just distributed it. But in vector land, that is called scalar multiplication. Just new words for same concepts. Real numbers are called scalars. Okay, now what do you think that means?
Absolute
something
value.
whack. It's not absolute.
Well, it uses absolute value notation, but it doesn't mean absolute value. Well, that's not quite true. It could mean absolute value in the strictest sense of the word. When we say on a number line, when we say what's the absolute value of 3, I know it's 3, but what does that 3 mean? Distance from 0, right? So in 2 dimensions, here is my vector v. It has coordinates 3, -4. Now, your question might be, Ms. Ford, how'd you know where to draw it? Well, if all I know is a vector's coordinates, I don't know where to draw it. I don't know where this thing starts and stops. All I know is that it goes right 3 and down 4. So to make my life easy, I'll start it at the origin. but it could start up here and it could start over here. And it's gonna look exactly like that no matter where it's drawn. Does that make sense to you? So just to kind of standardize it, I'll put it at the origin. Now, this is the tip of that vector, the end of that vector. Here is 0, or the origin. When we say absolute value here, we mean how far is the end of that vector from the origin.
A squared plus B squared equals
So we're just going to do the Pythagorean theorem.
Cheating.
This notation is the notation for magnitude. How long is that vector?
5.
5. This notation means magnitude. How far are you from start to finish?
You can just write that as a 5. You don't have to put it in
5.
the end. Okay.
5. Okay? Alright. Alright, now we have another situation. We have the coordinates of the vector from A to B. And we know that point A is 1, 4, and we want to find point B. Any thoughts on that?
6.
I heard a 6 and a 6, 7.
You're just gonna add 5 to the x value and add 3 to the y value on A.
Exactly. So if you think about what's happening here, here's point A, which is 1, 4. Here's B, which I have no idea, but I know that to get from here to here, I go right 5 and up 3. So if I go right 5 and up 3, am I at 6, 7? Easy. Easy. Now we're going to take a couple of vectors here. And we are going to add them. Any thoughts on that?
You add them. You add the x's, and you add the y's.
So the
So
negative
-7,
7,
2.
Yeah.
Oh my gosh, this is easy. How about 2b minus u?
negative 14, negative 11.
Well, I'm gonna start
Oh,
with
sorry.
negative 14, negative 6, right, that's 2b.
Just like,
And then I'm gonna subtract 0, 5. So you said, Jack, negative 14, negative 11 is our final answer? E. Find a unit vector in the same direction as negative 7, negative 3. And we're also gonna do it for 0, 5.
So like make one up.
You haven't thought. Let's start with this. Let's start with B. We're gonna find a unit vector in the same direction as B.
Well, this is my guess. Would it be like 1 and 4 and then negative 6 and 1? Like 2 points that would get you that vector, or is that incorrect?
That's incorrect. But those are 2 points that would get you that vector. How many such points are there?
Infinite.
Infinitely many,
Okay.
yeah, infinitely many. What do you think it means to be a unit vector? What are we even looking for? A unit vector. What's a unit circle? Radius is 1. What do you think a unit vector is? Its magnitude is 1. So let's think about this for a second. Here's negative 7, negative 3. There's negative 7, negative 3. How long is that? What is the magnitude of that vector?
58. Or square
square root of 58. So vector V is root 58 long. Is that okay with everybody? X squared plus y squared? I want a vector that's in that same direction, but I only want it to be 1 unit long. So first of all, would you agree that's in the same direction, same slope? But now it can only be 1 unit long.
Would you put like -7 over square root of
No, very good, Jack. This is -7, -3.
58?
If you want this side to now be 1, you're going to divide it by root 58. Now it's 1. But you can't just divide that one, you have to divide them all. So the coordinates of the unit vector in the same direction as as V would be -7 over root 58, -3 over root 58. How do we make a vector a unit vector? We simply divide it by its magnitude. That's called similar triangles from geometry, remember that? Proportional. Okay, do the same thing with U now. You do U. What is the unit vector in the same direction as U? What's it gonna be?
It's gonna be 0 over 5 and then 5 over 5.
Okay, which would be 0, 1.
Yeah.
Exactly,
You can't really
exactly.
make
So we divide by its magnitude. Think about, what does 0, 5 look like? Isn't this 0, 5?
Yeah.
Well, if you shrink that down so it's only 1 unit long, will it be 0, 1? Okay, easy. How do we make a vector a unit vector? We divide its coordinates by its magnitude. Okay. Now we have F. Now, vector operations are a little bit different because in regular math class, if I said this or if I said this, those would mean the same thing, right? Because we have two symbols for multiplication, right? Well, in vector land, those are very different. In vector land, this is literally called the dot product. And this is literally called the cross product. And they are completely and totally different. The dot product is a number. So when I find v dot u, it's going to be a number like 6 or -5. But when I do v cross u, I'm going to get another vector. They're completely different operations. We will never say v times u. That doesn't make any sense. We need to know if it's dotting or it's crossing. V cross u, v dot u. All right, so we're looking specifically at the dot product. We're looking at the dot product. And we are dotting -7, -3 with 0, 5. We're going to find the dot product of those two vectors. So easy. -7 times 0, -3 times 5, add them up. So first times first, second times second, add them up. Now, in our next class, we'll look at a matrix operation that is very, very similar. But right now we're doing the dot product, x times x, y times y, add them up. So the answer to the problem is negative 15. Good?
So what would it be if you were looking for the cross product of that?
Okay. You can't cross two-dimensional vectors.
Oh.
You have to have three-dimensional vectors, so I can't cross these. Good question, though. The cross product is actually not part of the AP curriculum, I don't think. I haven't found it anyway.
So we won't do the cross product?
No, we
Oh,
won't.
okay.
You won't this year for sure.
Okay.
Whether we do it in the future or not depends on what we discover. It's part of our old curriculum. We would do it in our old curriculum. But I do want to pause here for a second. We're going to do this next. Actually, let's do this next problem, then I'll pause for a second. All right, so everybody figured out how to do the dot product? Easy. First times first, second times second, add them up. All right, so now the question says, take these same two vectors and find the angle between them. So would you agree, you got this one sticking straight up, basically. You got this one sticking down in quadrant 3, and clearly there is an angle between them. How do we find that angle? Well, it's very easy. To find the angle between two vectors, you set the dot product, which we already found out, that's negative 15. Set that equal to the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them. So the dot product equals magnitude times cosine. Now that can be proven mathematically. We're not going to do it because our hours are limited here. But take your dot product, okay? Set it equal to, all right, what's the first magnitude? What did we get here when we found the magnitude of it? Well, we already did it, but if you forgot, the magnitude of V is root 58, and the magnitude of U was 5. Cosine of the angle between. So if we take negative 15 and divide it by root 58 and 5, that'll be the cosine of the angle. So what do I need to do?
Inverse cosine?
Yep, second cosine, make sure you're in radians, because everything we use in radians. Although some of my problems I do in degrees, because I'm an idiot. But here we go, second cosine I got theta to be 1.976, but double check that for me.
Yep.
Are we okay? All right. Now, before we move on to the next thing, which we're going to be shifting gears, before we do that, I want you to find the angle between these two vectors for me. So this is not on your sheet, so somewhere if you find a place to write this down. Let's say vector A has coordinates 6, 4, and B has coordinates -2, 3. And let's find the angle between them. Okay. So what's our process again? We find the dot product and set that equal to magnitude times cosine. Anything interesting here?
The dot product is 0.
The dot product is 0. Okay, so let's talk about that for a minute, Jack. The dot product is 0. So I would have 0 equal to magnitude times cosine. Does it really matter what these magnitudes are? When I divide, it's gonna be 0 equals cosine. Wait a second. What angle has a cosine of 0? Pi over 2? Pi over 2, 90 degrees. So the angle between these two vectors is 90 degrees, pi over 2 radians. Wait a second. How does this vector move? Right 6 up 4. So isn't his slope 4, 6? This one goes left 2 up 3. So his slope is -3/2. Wait a second. What do you notice about those slopes?
They're perpendicular.
They're opposite reciprocals, which means they are perpendicular to each other. In vector land, perpendicular is called orthogonal. So orthogonal is the vector word for perpendicular. I told you, it has its own vocabulary. They talk about orthonormal vectors.
Is that like a word? Is that like in the dictionary, you think?
Orthogonal? Sure.
What's it mean?
It means
Besides-
perpendicular.
Oh, it's just this? Okay,
Yeah,
thank
it
you.
means perpendicular. Okay, isn't that cool? See how all the pieces come together? So neat. All right. All right, so now we're gonna we're moving on to number 10. You know all that, yep. And we're gonna solve triangles. When all of we math teachers sat down and started talking about this AP stuff, one of the big things that was lacking, well, it's not lacking, it's in Unit 4, I'm glad we're getting to it, is how to solve triangles. That's a huge part of trigonometry, is how we solve a triangle. Now, I've done this in degrees. Since we're doing this extra, I guess it really doesn't matter. So I did it in degrees. Certainly there are radian measures that correspond with those that we learned this. Now, when we solve a triangle, what we mean is find all the missing pieces. So, triangle has 6 pieces. It has 3 angles. I am missing angle C. And it has 3 sides. I am missing side H, and I am missing side S. Now, have you guys done this before, so you know that the sides are labeled across from their angles?
Yeah.
Okay, so those are the missing pieces. Now, one of them is a no-brainer.
C,
Right.
it's 10.
We know angle C is what?
41.
No, no, angle C, that's a big C.
Oh, 41
This is a
degrees.
little c.
Ooh.
41.
41? How did you get 41?
Sorry, minus
Okay, so if I had done this in radians, then it wouldn't be 180 minus those, it would be pi, no pi. Pi is 180.
Oh, right.
Pi is 180. So pi minus whatever. Okay? This is in degrees, so 41 degrees. Now we have something called the law of sines. Did you do that in geometry? The law of
Oh, wow.
sines. So the law of sines looks like this. It is very easy to use with one exception. It does have a corpus. But usually the law of sines is super simple. So, right here is one of my ratios. Sine 41 over 10. Now, I know this says A, that says C, I don't care, put it back here if you want, right? The idea is the sine over its side. Now, what am I gonna set that equal to? That's up to you. Could we say sine 81 over H? Now, stop there, we can't handle any more at once. I know we got more to do, but that's all we can handle. So I'll cross multiply. So H sine 41 equals 10 sine 81 and divide. Now, before you type this in on your calculator, remember these are degrees. So you are gonna need to change your calculator into degree mode. Or it won't. So 10 sine 81 divided by sine 41. Did you get 15.055?
Mm-hmm.
Now, please don't try to use the Pythagorean theorem or something crazy. This is not a right triangle. So to find the other side, we're gonna have to repeat. So we'll go back to sine 41 over 10. Always go back to your given when possible. Sine 41 over 10. And this time we'll set it equal to sine 58 s. .926, is that what you came up with? Okay, we love our law signs. Now, there is one little glitch we'll talk about, but usually the law signs is like our favorite thing, it's so easy. Okay, let's look at the next problem.
Ooh, it's like backwards now. We haven't got it.
So tell me what we're gonna do with this guy.
Ooh.
Let's see, we gotta find side, or angle C, angle S, and side H.
So the sine of 52 over little h equals the sine of s over 10. I don't think we can do that, but
Is that a little problematic? It's
there's-
absolutely correct,
There's two
100%
variables
correct,
there, you couldn't solve it.
but can't solve it because there's too many
Would it be,
variables. Okay, in order to use the law of sines, does it make sense to you that you have to have at least one of these pairs? You have to have at least one of these, you have to have one of these complete fractions. If you don't have a complete pair, angle and side, angle and side, angle and side, if you don't have a pair, then this is not going to be solvable, because this is what's gonna happen. Are we clear on that? So, law of sines is always true. This is a true statement, but it's not solvable. So if the law of sines isn't solvable, we'll go to the law of cosines. Between those two, the law of sines and the law of cosines, every triangle is solvable. If it's a solvable triangle, you can solve it either with sines or cosines. Now, do you remember what the law of cosines looks like? Did you guys ever do that one? It looks a lot harder, but it's really very, very easy. So, the law of cosines, I'll write it down for you, but I really don't want you to memorize it all. The law of cosines says something like h squared equals c squared plus s squared minus 2cs cosine h. So again, that is not something that you're gonna put on a note card and memorize. You're gonna memorize how it works. So, look at our triangle. How many angles did we know in that triangle? One. That is the only angle in the problem. And notice it's out here at the end, cosine h. On the other end of the equation, all by itself, is that side. So if you got a cosine h out there, you're gonna have a h squared over here. If we had cosine s out there, we would have s squared here. Okay? Now, what's all this stuff in the middle? Well, notice, everything in the middle is just a combination of the other two sides. So if this had been an s squared, then this would be c squared plus h squared minus 2ch cosine s. That 2 is part of the formula, it is always there. So, I want you, I don't care, if you wanna memorize it, but do you see how it works? Alright, so let's go ahead and start plugging stuff in. I don't know what h squared is, but c squared is 144. And s squared is 100. So c is 12 and s is 10. And h is 52. So obviously we're still setting degrees. Now be careful, because when you get all that typed in, what does all this equal? H squared.
You have to square it in.
So you gotta square root it. You have to square root that answer, and it's 9.810. So H is 9.810. We're in degrees. This is, oh, I didn't put in degrees, I'm trying to clearly that's a degree. 52 radians would be huge. Number 6 is a revolution. So 52 would be like 8 and some revolutions. Couldn't have that problem. Did I type it in wrong? Wrong? I see some of you kind of questioning me.
I got 9.81.
Is that what you got?
Yeah.
Okay. All right. Now, where do we go from here? Well, now I want you to notice something. What do we have now?
We have a pair.
We have a pair. So now, can we go back to our law of sines? When we do go back to our law of sines, though, guys, make sure that you are not using this rounded off answer. Use the number that's in your calculator. So sine 52 over the h that's in my calculator equals sine s over 10.
Very weird number.
So 10. Press something away. There we go. So 10 sine 52 divided by. Now, when you do your cross multiplying and dividing and all that, you're going to end up with sine s equal to a decimal. So what do we do with that decimal?
Inverse sine.
Second sign, that's right. And 53.44.
Yep. And then after that, you just subtract it from
And
180.
after that, we just subtract from 180. That was 442. I got 74.558.
Yeah.
All right, 2 more and we'll be done for the day. All right, take a look at it. You're solving this triangle. This time, we don't know any of the angles, but we have all the sides.
That's good.
So, is it gonna be law of sines or cosines?
Cosines.
Gotta be cosines, because remember, we don't have a pair. So it's gonna have to be cosines. So let's find, randomly, we gotta find something. Let's find the biggest angle. Which one will be the biggest angle? H. So let's find angle H. So if we want angle H, then we're gonna have cosine H out here on the end. And what are we gonna have over here on the other end?
14 squared.
14 squared. And what's that, all that junk in the middle gonna be?
12 squared plus 10 squared
100
minus 2 times 10 times 12.
Yep. How's that look to everybody? Obviously, the order here doesn't matter. Right, we're adding, so it doesn't matter. Now, I want you to be real careful when you type this in. I probably don't need to warn you guys about it, but I have students who always just want to type all this junk in together and get a number here. You can't do that. You can type these in, right? And you can type these in, but they gotta be kept separate because that took to a cosine. All right, go, see if you can find angle H.
So 78.463.
That's what I got, 78.463. I want everybody to catch up to that. So if you're having trouble getting that, you got 14 squared, subtract your 12 squared, and subtract your 10 squared. So then you're gonna have this number equal to negative 240 cosine H. So whatever you got over here when you subtracted these things, divide by negative 240 in second cosine, inverse cosine. Get it? Got it now? All right, so what's next? We're solving the triangle, so what's next?
Log signs.
We could do the lost signs, or we couldn't we repeat it, everything we just did, but find angle C maybe? It's up to you completely, go. Do it one way or the other. You're going to find another angle, either with the lost signs, or you'll redo the law cosines.
Mrs. Ford?
Yep.
If it's easier for us to remember, can we just write all the decimal points in the answer? So like when we round off, or do we have to round off?
Oh no, you never have to round off.
Okay.
No. Now I lost my train of thought. What am I thinking at
Did you get? Did you finish it?
No.
Here's what I got for him, I don't know what.
That's exactly what you got.
Does does the rounding matter? Yeah.
What do you mean?
Like to the thousands on our final.
Well,
I got
in this course, we only found,
57.121, and the rest were the same.
okay, make sure, did you do the law signs?
Yeah, and I
Okay,
subtract.
when you did the law signs, you have to make sure that you're using this whole angle, that's the one we found first, that
Yeah,
whole
I used,
angle.
I found S and I didn't see it.
Okay, but you used this to
Yeah.
find it. Did you use this number, or did you use the whole
number.
decimal?
Whole number. Whole decimal.
Shouldn't have been off that, I don't know. Shouldn't have been off, so I don't know.
Yeah.
Maybe you just
You
rounded
rounded
wrong.
wrong.
I just didn't round
You got
it.
the right number.
He rounded wrong.
Yeah.
Okay.
I had it.
All right.
It's not bad.
All right, so now the next one, here we go. Got some stars here because remember I warned you that once in a while the law of sines is trouble. I love my law of cosines because it never lets me down. law of sines, this can be an issue. We can work our way through it. Here's what we need to do. First, we need to figure out what the issue is. Okay? So would you absolutely 100% say this is a law of sines problem? Yes,
There's a pair.
because we have sine 53 over 9. That is a law of sines problem. And we'll set that equal to sine S over 10. Alright, so let's find angle S. I'm gonna write this down just for purposes of this problem, even though I would never do this, really. I got 62.545, what about you?
Yep.
Okay. Now, let's talk about why this is problematic, but the problem we just did wasn't. When we got cosine H equals 0.2, and I'm making that up, something like that, 0.2, but I don't remember what it was. But when we got something like that, there is, in a triangle, we're talking about a triangle now, there's no issue. Because remember, we already learned that if the cosine is 0.2, that angle could be in quadrant 1, or that angle could be in quadrant 4, right? When you have this expression, you gotta be on the lookout for two angles. 1 and 1, 1 and 4. However, if we're doing a triangle, this can't be possible because that angle would be between 270 and 360, right? So this doesn't cause me any problems at all. That is fine. But when we have something that says the sine equals 0.88, where could that angle be? Certainly in quadrant 1,
Also in quadrant 2.
which is 62 point whatever, but it could also be in quadrant 2. And can triangles have quadrant 2 angles?
Yes.
Yeah, you could be between 90 and 180 in a triangle. So we not only have to consider the one we got, but we have to consider the other one, which we will find how. 180 minus the first one. Won't this angle be 180 minus that? So that would be 117.455. So in other words, what we're saying is, there's actually two angles that could be. Now, I need you to look at this carefully. Would it be okay to have in a triangle a 53 and a 117? Could that happen in a triangle?
Yes.
What do they add up to?
170.
170. That leaves 10 left over for this one. Triangle would look weird, but it's possible. It's possible. So there are actually two possible triangles for this set of given information. One of them has the angle 62.545, and the other one has this one. So you have to do two problems. You have to solve this triangle, and you have to solve this one.
Yeah, how would you know if there's like two different angles?
Like what's the sine?
Well, wait a second. Why were there two different angles? Why were there not two different angles in my cosine problem? Because the second one would be in quadrant 4, between 270 and 360. That can't happen in a triangle. So with cosine, I never have to worry about it. When do I have to worry about it? When I'm second signing. When I'm inverse signing, I have to worry about the possibility, not the guarantee, the possibility. Because what if this angle had turned out to be 147?
That is impossible.
Then that would not be possible, so I would just have my one triangle.
So if you use the law of cosines,
You can't, you don't have the right information,
oh,
you have too many variables. Yeah,
man.
No, you're stuck with it. Now, I wanna say one more thing though. We'll come back to this and talk about it tomorrow. But I want you to look at what was the information given in the problem. And I want you to go back to geometry class. Look, this is what you were given. You were given angle, side, side. Now, the other problems we looked at, we had angle, side, angle, or we had side, or side, angle, side. Those were all fine. Why is this one not fine? Angle, side, side is not a congruence postulate. Remember when you did your proofs? Could you use ASS? No. Your teacher probably said, it makes a bad word, don't use it. It's called the ambiguous case. And the reason it's not a congruence postulate is because of this situation. You don't know whether you got one or whether you have two triangles that meet the qualification. Okay?
We do not see you tomorrow.
Huh?
We do not see you tomorrow.
Oh, did I say tomorrow?
Yeah, sorry.
Whenever
I just wondered. So then we'll see you at the review period then.
Whenever we're together again, yeah. So, your homework is to finish, or, what is it, 7 through 10? Is that what they are? Yep, you're gonna do 7 through 10. So basically, start with number 7 and finish the sheet. And then I will have a couple more things I wanna talk about.